For now, we can start. First of all, let me start with things not so related. Yes. By the way, it would be nice to have your videos on as well. I mean, seeing reactions might be helpful. Besides, I turned on a chat window for myself, so you can ask questions along the way in the chat. Or if you want to ask a voice question, you can raise your hand. Just would like to avoid any congestions when everybody starts speaking. So raise your hand. I mean, there is a button, if you don't know this. There is a button in the panel below. And so I can see and I can give you a word. I don't want this to be a classical lecture. As I said, as I probably wrote it in the post, I want this to be more like a seminar where everybody can speak, discuss, ask questions, and so on. Of course, the leading role is mine, and still it's a seminar combined with a lecture, but still something, like hybrid solution. Stop telling me you have this new device. First thing. Second thing, as I said, I started YouTube live translation, so later you can see it all on YouTube. And third thing, more related to the content, to the actual content, don't expect it to be too advanced. If you know more, then you would have to listen to all the basics, starting with the very, very basics. First, this is because I don't know who are you, what background you have, and so on. Second, because of the YouTube translation. The very same thing might be watched by anybody later, and I would like them to have access to all the information they need. Because the idea of this course was brought up to life by a discussion where a phrase was said about too high threshold of entering Rakudo core development. And the primary point is to make this threshold easier to cross. We cannot make it lower, but we can give a helpful hand those who steps over it. Then, totally unrelated thing, you see this flag on my background. You see this flag on the front page of the presentation. Two flags actually. If you didn't know, the black and red flag, it's a flag of militaries in Ukraine, and it's actually what blue and yellow turns into when they're soaked in blood. So that's highly symbolical flag as well. And the QR code you see on the left, it's a PayPal account where you can help me help a squad back in Ukraine. We buy a lot of things to them, mostly related to uniforms of different kind, and believe me, it's pretty much costly. So I don't ask any money for the course itself, apparently, but if you can help me later, anyway, using this PayPal account, sending me some money, I would very much appreciate it. Ukraine really needs our help now a lot. Um, with this respect, I have one special note to Martin. Sorry, I know you're from Hungary. I don't know what your political views are, but Hungary currently is actually an enemy to Ukraine. It's the only European country which openly supports Russia against Ukraine. So I very much ask you, uh, keep silence if you support your current government. Okay, I don't want to bring it in here, but anything said against Ukraine, I will react. You know, my reaction will be very unpleasant. So it's very sensitive subject. Now let's get over this and let's move on. Come on, why doesn't it? Okay, it changed. Basically, I said most of the things about the content. Now, what I expect from the audience. As I already said, don't want people to know too much because everybody with little knowledge can do something. So the basic things I require here to know is GitHub. It would help you very much if you know C and C compilers, though we're not going to discuss it in this course, but you will need it later. Very likely you will. Also, know as much about Rakulang as that it's dynamic but compiling language. And you should understand what does it mean. I'm not going to focus on this too much. So for the beginners, the very basics, where we start. First of all, I need to make this more readable. Okay. First of all, where we start with GitHub. When we compile Rakudo, the first thing, of course, we clone it from the repository. But that's not what we do when we develop for Rakudo. Note this little button on the top of at the top of repository page. It means you can fork the repository from where it lies originally into your own repository, into your personal repository. And that's what I want to do everybody who starts working on Rakudo. When you're done forking it and you got your own copy of the repository, then you can clone it locally and work with that copy. That's how we do things in first place. My apologies. My coffee arrived. The reason we do it is because the most simplistic way of doing development, the easiest way, is to commit directly to the original repository. And we better don't, because the price of error is gonna be high in this case. Best approach we use is to work on your own copy and then later create a pull request. I think I'm gonna have it a little bit later anyway. So let's focus on forking. The next thing to do is to fork not only Rakudo itself, but to fork more VM and NQP. Because sooner or later you're gonna work with them too. And again, not immediately, but later you will need them. To make things easier, when you configure your Rakudo installation, you can use GitHub user command line option with configure PL script. This way, you can tell the script your username on GitHub, and it will clone everything from your user account. So to say, you have your local copy of Rakudo, you start configuring it, you give it GitHub user, and it tries to clone NQP and more VM from your user account, not from their original location. It makes things to work with much easier when you need the whole stack, and you need to work with the whole stack. Sometimes GitHub user, it's like an atomic bomb. It might be too much. In such cases, you can clone each individual repository separately using corresponding command line option. You can read about it later, just know it's possible. Next thing to do is when you got your local copy of Rakudo, it's actually frozen at the point when you clone it, when you forked it. But often you need latest changes from the master repository. In this case, the easiest thing to do is to add a new remote to your repository. Like, the default remote you have is origin. And this is where Git pulls all changes from by default and pushes to. But you can add other upstreams, other remotes, and I normally call the original one upstream, and I add upstream to my current repository whenever I clone from my own copy. And later, say I created a branch, I work in this branch, I've done some changes, I've done some commits, and then I realized that I need some fresh commits from the upstream. That's the command line I use to pull them in. This way, you create the smallest amount of conflicts. Possibly there will be no conflicts at all, because what happens with this command line of Git is that all your changes temporarily put aside down to the latest commit from the original repository. All new commits are pulled in, and all changes you've done, they are rebased on top of the new commits from the upstream. You can read more about it in Git. So just you see the command line, and you can use it. For simplicity, if you want, I left it in the chat as well. So that's the very, very basics of working with repositories. And now it's time to actually, we have all the copies. It's time to go into our, excuse me, to walk into our working directory. Okay, and here we go. Let me use another copy. So normally we're gonna have something like that. My copy is apparently have some build binaries in it already, but generally we are ready to start and do something. And the first thing we do, of course, reconfigure. Again, that's the most typical thing I do. When I don't need, to work with NQP or with more backend, then this command line is totally sufficient to prepare for building. So that more, as you can see, is my primary backend. We'll get to backends later, but for now, that's all we need. What happens next? After we build Rakudo using make install, we'll get all the binaries, all the libraries, everything installed locally in the build directory under install subdirectory. You can choose any other directory, of course. When you do configure PL, you can use prefix and specify some other location. No big deal, of course. I like it more this way because I like having everything under my hands. So that if something goes wrong, I need to wipe things out, just nuke all the installation. I nuke it right here, right now with one command. Now, step aside from building the directory structure. First, directory where we can start really doing something is lib. Lib is where Rakudo keeps its system modules, I would say so. It's not core modules, but because core in Rakudo means slightly different thing. So let's call them system libraries, system modules. As you can see here, what we have test, which we use for our tests in our modules in our software. And we have a number of other modules. You can find more about them later. Another one, I would say it's the second widely used module is native call. Native call is nearly ubiquitous, and I would be very much happy if somebody get time and work on it, because we know it's having problems, and my own software I wrote for my second job. I suspect it suffers from problems in native call, and I can do nothing about it, unfortunately. Okay, so if accidentally you stop at this point and doesn't continue listening to this class any further, at least you know that lib is where you can do something for the core development in Rakudo. And oops, my apologies. Okay. But let's get back to the installation itself. When you develop for Rakudo, of course, you can get into problems. You can break things down. And at the same time, you would need to test some third-party modules with the build, with your own build, or you would need it for something else, whatever. So the point is that in different situations, one may need both some default version of Rakudo and a build version of Rakudo. To solve this, not a problem, but issue, I prefer to use Rakudo. Rakudo allows you to switch between different versions of Rakudo very quickly. Each version would have its own set of modules installed, and so on, so on, so on, so on. So Rakudo is what I highly recommend. You can find out more about standard commands of Rakudo. The only thing I would tell is that to use your own build, that's the command I use. First thing, I register a new version of Rakudo. I name it build because I built it regularly. And I specify the directory where it's installed. In my case, it's where my Rakudo copy is clone is done and install where it installs. And that's all. Then anytime I do Rakudo switch build and I work with the build, then I need other version. I do Rakudo switch, say more dash 2020.10, and I can test things with Rakudo 2020.10 release, something like that. Okay, here I use 2022.07, whatever. Now, back to the directory again. A little bit more details. What's the most important to know about the directory structure? First, NQP. This one actually doesn't belong to Rakudo. This is where your copy of NQP source code is installed. This is done for you by configure script, and actually you can use a separate directory. You can clone NQP repository somewhere, some other location. You would just need to point out to that location your configure script so it knows where to pick NQP binary from. But by default, this is where it goes. And I see it as a very convenient shorthand because, again, I often work with the whole stack. Even if I don't do something to NQP, and I actually quite rarely do something to NQP, it's pretty stable. But sometimes I just need to find out some things, find out how things happen inside NQP, find out about maybe some methods in NQP, whatever. And it's just very convenient that it's sitting right here in my directory tree, and I know that I quickly find everything when I need it. Next thing, tools. Tools is directory for anything which is not directly source related. You can find some pro modules in it. You can find templates, and templates is what you would very likely need sooner than anything else in this directory. I don't think I'm gonna speak about templates because, again, it's a kind of thing you barely would change too often, except maybe for a list of source files. But again, it only happens when you add a new source file or maybe remove an old one, which also not something we do often. Bleep contains all intermediately precompiled files. Again, we don't need it often, but sometimes it plays its role. Gen is way more important. It's also a location for intermediate files, but it's a different kind of intermediate files. The actual sources we use to build Rakudo. What I mean here is that we should later have a look inside the source directory, and I think I overlooked it in my presentation. Probably I did. Okay, I'll fix it now. But when we build Rakudo, most of the files we find in SRC, they are not self-sufficient files. You can find some .pm6, well, legacy, some .pm6 files. You can find some .recomod files, but they're not actual modules. They're just chunks. And those chunks are put together in special order and placed into a single file. And that file actually represents the unit of compilation. That's our source. And Gen directory is where that file is placed. Another thing to know about Gen, it was too much to be placed into one location, but if you look inside it, you see we have few second level directories, more, JVM, and GS. Those represent different backends. Again, backends, I'll leave for it later. Most of you know what backends are, but it might be useful for somebody who doesn't know that well. The point is that not all code we have in the core is meant to be for every backend. And so we kind of pre-process source code, and when it's pieced together into single compilation units, there might be some pieces missing. Those pieces we don't need for this particular backend. And that's why Gen is important, because when sometimes when you locate a problem, the only way to find out about the problem and where it stems from is to look into Gen directory. Well, actually, well, I went through this slide already. The only thing is I missed an example of how it happens. You see, if we try this command line, we can see this error message below. And as you can see, it points to GEN directory. And line number, it is related to file in this directory. So even though we have compiler in QP in our SRC directory, it's not the line number for that compiler in QP, but for the one we find in GEN. Okay. Components of Rakudo. Why is it important that Rakudo is a dynamic compiling language? It's important because Rakudo binary is not the only thing involved into compilation and execution of Raku code. Moreover, Rakudo as such is just a launcher. Well, actually, it's dynamically linked to necessary dynamic libraries. So eventually, yes, eventually you get the whole binary in memory, but things a little bit more complicated than just that binary. So what our runtime consists of? First of all, of course, a backend. A backend is something what executes our byte code, of course. You know, we currently have more VM backend, the most efficient one. We have Java backend, and kind of we have JavaScript. Though I don't remember when was it the last time anybody committed to JavaScript backend, and I barely expect it to be compilable nowadays. But there are a lot of code related to JavaScript, and anybody willing to pick up that project can create something which is runnable by a browser, for example. Though probably nowadays it makes much more sense to create WebAssembly backend, which we just don't have resources to work on. And people probably, we don't even have people sufficiently knowledgeable with WebAssembly. NQP is a level on top of backend, and when we say NQP, this term actually has two different meanings. One meaning is it's a compiler, and second meaning it's a language. The reason we separate them, not only because every language in Rakudo ecosystem, in Raku ecosystem, any language can have more than one compiler. It's possible. So if you want to start your own Raku compiler, you are very welcome to do so, except that it would be a waste of worthy of valuable resources. But anyway, I mean, it's possible. Whatever. Same about NQP. It's possible that somebody writes a compiler for NQP, though I don't see any sense in doing so whatsoever. But still. So we have a language and we have a compiler. But more importantly is that NQP is widely used in Rakudo core. NQP is language. We'll get back to it. So again, When I say NQP, I need to be more specific whether I speak about compiler or I speak about the language. And the topmost component is apparently Rakudo itself. Rakudo is built for a backend, and it's built with NQP as the bootstrap language, and proceeds compiling its own code when the compiler itself is ready. It's a little bit complicated, but we'll get to it, of course. And step by step, I hope things are getting more and more interesting. How does runtime work? So when you do something like this command line, of course, the first thing what happens is Rakudo binary gets started. And by binary, I mean your operating system binary. But the binary itself, it's just the backend. Because what it does, as I said earlier, is that it pulls in the dynamic library of, okay, let's focus on more VM. Let's skip Java VM for now. So it pulls in more VM dynamic library, and that's it. What it does next, it just pulls in bytecode of the actual compiler. So Rakudo compiler is not written in C, it's written in NQP, and as such, it's compiled into bytecode, and binary pulls in that bytecode and starts it. And it does so by passing that bytecode to the backend. Next thing, compiler bytecode actually pulls in your Raku code from the program.raku, from the source file, and compiles it and creates some bytecode. And that bytecode is submitted back to the same backend, and then it produces some outcome. And what I would like you to keep in mind here in all this diagram is that the same backend is used for both compiler bytecode and your program bytecode. And by that I mean not that it's the same binary, but it's the same address space. So your bytecode can actually use compiler for its own needs. It's possible. That what means to be a dynamic language. Dynamic compiled language. Sometimes it plays a very important role in some processes inside the compiler itself, because NQP happens to work in the same way. And so Rakudo compiler uses it for doing some clever tricks to implement some language features. Sorry, just checking out my notes. By the way, your code does the same when you use eval, because when you eval something, it's totally the same process. The code being evaled is compiled, bytecode produced, and submitted back to the backend. So it's executed again in the same address space as your own code, compiler code, and so on, so on. And the diagram looks rather simple, but sometimes things are not that simple. Because when it comes to execution, one of the biggest problems when you fix a bug, when you get an error of some kind and you know where the error took place, and you traced it down to some location, say in again directory, some file, some line, and you see that, well, it's been reported here, but then you try to trace down the region of the error, because the place where it's reported, it could either be some kind of exception throwing, or it could be just inducted error. Like the regional error is different, and what you see just side effect of it. So you need to know the full call stack. It's not always that simple. It's not always that easy to do, because things may turn to be pretty much convoluted. Say we have some Raku code. That Raku code does the call to Raku core, some method, for example, whatever. And that call is somehow processed and ends up in NQP. By NQP here, I mean NQP runtime, NQP core, because it's a language on its own, it has its own core. And NQP in turn, it may call backend. And backend can use some kind of callback table. Like at startup, we can register a set of handlers for different purposes, and they are stored internally by backend and used whenever necessary. And in this point, you actually can lost the track of the error, because when backend invokes some code from Raku core using this callback table, like, I have this situation, I have this code to execute, and they call it. There is no way you can see it in your backtrace. It's a problem. I know I've been there many times, and one just need to know that it happens. And there are other ways to locate problems of this kind. Just always remember, there is somewhere a table, and there is somewhere a place where entries in this table are placed. You would need to figure out where it is. My my way to do it is basically use grep most of the time. Like for example, let's have a look at how can I find it? And here we go. Yes. Is it readable? Do you want me to make the font larger?
Yeah, well, the quality fluctuates a bit.
Okay. Still like this. So what happens in this piece of code? Don't pay much of too much attention to the code itself, but here we see an exception gets thrown. Type check assignment. This is where our error about wrong type comes out if we try to assign, say, a string into an integer or whatever else. And if you need to find out where this error comes from for some abstract reason, it's not easy because it's not a method. It's not a subroutine as such. It is a subroutine, but it's actually a stripped down version of subroutine, whatever. Not for now. So what happens here is that we set up a container specification here, and we set up it by registering a special kind of table with handlers. This one is the handler for store, which gets invoked when we store something into a scalar container. So basically, nothing complicated. When you know what it is and where it comes from, it's not a big deal. But when I needed to know this code, like about 3-4 years ago, I don't remember already, it was a big pain in the ass to find out what's happening. And the only way to find out was to locate this keyword. And then I found it in more VM backend source code. And then I was able to trace it down to setconspec, find. And grep was a huge part of debugging in this case. Let me see. The window is small and it's hard for me to follow what's coming next. Okay. Now grep is your tool, and also keep in mind that we don't have a debugger. Rakudo doesn't have a debugger for its own code. That makes things much harder to solve. Testing, it's mandatory. I mean, when you develop for core, just never skip these two commands. Plain, never. Whenever you did any kind of change, test it. I don't mean immediately after you edited your code, but certainly before you submit a pull request. You do test and you do spec test. Just again, never, ever. Make spec test. What it does, it runs tests stored in roast. Roast is our specification. It's a set of test files And only when all those tests are passed, our compiler can be considered as conforming to Raku standard. Sometimes people do a mistake by saying that all ROS tests must be passed for a compiler to be named a Raku compiler. This is not correct. Rakudo itself doesn't pass all the tests. We have a lot of to do, a lot of just dying tests, which are simply excluded for now. The point is that just how many tests have been passed. Just intuitively, we can say that, well, yes, we conform to this standard. Just don't break those tests which are already passing. If your compiler does pass something and your change breaks it, well, you cannot mark it as to do or skipped test. No way. Backward compatibility is not to be sacrificed. Next thing, you have done some change. It is ready to be submitted. You create a PR. Don't forget, if it's not a bug fix, then please, if it's a new feature, or maybe it's a bug fix for which there is no test in Rust for this bug, create an accompanying PR to Rust, which means absolutely add a new test to Rust for the thing you just got fixed or implemented. Always. And we are getting to Rakudo itself more than before, because more or less everything said before, it's like generic stuff. Core development as such. We all speak about core development, but what exactly does it mean? Because the term itself is rather generic. Yet there are two different areas, at least two different. In fact, there are more, but those more like okay, I don't have the right word. We have the actual compiler development. To the compiler development, I also relate NQP and more VM because they are used to compile the compiler itself. Even though NQP very much in its structure, it very much resembles Rakudo. It also consists of the same parts, compiler and so on. So we'll speak about it later. But still, when you work for NQP, I would say you work for compiler in first place. And therefore, it's compiler development. And there is core itself. Core as a setting. Core is language public interface. There is actually sort element, meta model, but it looks somewhere in between compiler and core. I would more relate it to core. So it's like some kind of gray zone. But one can say that meta model is a thing on its own. So and what I meant here is that when you say core development, if if you speak about something in particular, you better specify what you speak about, because otherwise it may create confusion. Core development as the most literal thing is when you change, say, behavior of some class like int or promise or whatever. That's real core development, not the compiler development. Now it's time to start speaking about the structure of the language as well. Again, all this might be familiar to you, but might be not so familiar to others. And it would be nice to refresh all this in memory, because it will have a very, very direct impact on what we do the most. So bytecode is okay, bytecode, but bytecode itself has its structure, and the core of this structure is blocks of codes we call frames. A frame is what you see in a backtrace as a single entry specifying line number, file name, line number, subroutine, whatever. There are more frames than we normally see in a backtrace, but whatever. So a frame can represent different syntax constructs. Backend doesn't care about them. All a backend see is just a frame as such. The weight C is very important because there are two different kind of relations between frames. First kind of relation is lexical. So a nested frame means that it can see symbols from its outer frame. We all know this because when we insert a block, a new block into our subroutine, this block can see variables or whatever symbols declared in this subroutine at high level. And we also have dynamic kind of relations. This kind of relation represents the call stack, the way our code is executed. Any frame can invoke another frame. It can kind of call it. So, like we put all our data on stack, we pull in another frame, we prepare a stack for this new frame, we pass all the necessary arguments, and we pass control to that frame. That's where we get dynamic relations. So I think it's not a big deal. It's not a big deal to get clear understanding of what's happening with this diagram. So I would not really focus on it. Just never forget that there is this difference. Okay. So let's get back to it. I was speaking about lexical resolution. So you can see lexical resolution means when you have a symbol and you don't have it declared locally in your frame, the language tries to find it in the outer frame, which is for block B would be a subbar. The symbol cannot be found there, so it goes one more level up to the outer, and it finds it in the outer of your sub, which could be, say, module or whatever. We don't specify exactly. Okay.
I remember
anyway,
you talking about lexicals. I don't remember you talking about dynamics.
Okay, so back to the dynamics then, briefly and quickly. Symbol din, first step. it gets looked up by dynamic path by looking up in subbar. And even though subbar is our lexical outer, and it looks like, accidentally like we look dynamic in our lexical outer, but that's different because we all must know that any block, any inner frame, it doesn't get executed just magically, but it's called, it's invoked as any code does. Because any frame, it's a piece of code. Would it be representing a routine of any kind or a block or whatever? It's a piece of code. And as you can see on the next step, dynamic lookup goes totally different way, and it goes directly to block A from where our subbar was involved. No lexicals are involved. And that's dynamical path of lookup. I'm very much sorry for being muted again. Okay, hopefully the diagram was sufficient, because there is nothing really complicated and we can find this information easily. So let's go further. Okay, the outer frame we saw in the previous example, as I said, it could be anything. But I would like you to consider it as a module, just a simplistic case. Again, I simplify things a lot. Still, let it be a module. It's our outermost frame where everything. Come on. So the outer frame from the previous diagram, most typically we would think of it as a comp unit, which is a shorthand for compilation unit. Sometimes people mistakenly treat it as a computation unit. No, it's not computation, it's compilation unit. Maybe. Okay, now I see. It seems, okay, I have to switch focus. When focusing and focus is in the browser window with JITSI, when I press spacebar, I get muted. Probably that's the cause. Come on. So a computational unit, it's also a frame. That's why it is important to remember and understand all those relations, because comp unit is the basic frame of it all. That's what our compiler deals with in first place. Actually, when you use eval creates a new comp unit for you. I mean, something like this. And this string here, it is actually a comp unit on its own, because eval compiles this string, and compiler cannot do it without creating a dedicated comp unit. So a comp unit is a frame. Normally, it represents a file. So when I say that let's consider a module, it was a big, huge simplification, because even a module, even though visually it looks like it, especially when we use unit module, it looks like the whole file. It is not. A module itself is a part of a comp unit. Okay. YouTube link to some related presentation. Yes, it's always useful to have it. So normally a comp unit, it is a file as such, but as you can see from the example with eval, it's not necessarily so. And even more with RakuAST coming, when you compile a RakuAST tree using eval, you also get a comp unit. So a comp unit is what is the only thing a compiler can compile for you. There is no way you can get some bytecode not wrapped into it. And also, it's the only thing your backend can start to execute. So when you get some kind of bytecode and pass it to backend for execution, it's not just plain bytecode of some kind. It's a comp unit which you submit to your bytecode. So never forget that, and don't be confused when you start working with actual compiler code with QAST, to which I hope to get maybe not today, maybe next time. But we need to know this. And our core is actually a comp unit. You remember, as I said, the core setting. It is a comp unit. And at this point, you will see why I was focusing on lexical dynamic relations, mostly on lexical relations, why I was focusing on frames and so on. Because our core setting, it's our lexical outer to any other comp unit we create. Well, almost to any other. Basically, when you execute a script, then what happens from this respect is your script is compiled. We get a comp unit for your script. Then the compiler pulls in core setting. There are nuances about it, but currently just pulls in a core setting comp unit and lexically puts your script comp unit inside the core setting. It makes it lexical inner of our core setting. So, for example, when you resolve a class from the core like int, what happens? It gets resolved lexically, not dynamically. Let me see. Yes, I think I'll get, I'll get to it a little bit later. This also means that when we speak about different Raku language versions, 6C, 6D, 6E, each language version has its own comp unit, its own core setting. And to each other, they're also lexically nested. So, for example, when you start your code with something use v6.e.preview, meaning that you want 6e Raku language version for your code, what compiler does for you, it takes your code, it takes your comp unit, it wraps it into core setting of 6e language frame, then into 6D, core, and then into 6C core. So that each one, your code becomes lexically the innermost code within 6C lexical scope, then 6D lexical scope, and 6C lexical scope. The way it works and the way it helps, I can demonstrate it to you in the code itself. Let's take what interesting do we have here? Grammar. Yes. For example, here, as you can see, we have a grammar class defined for 6E language. You can see it down here. There was serious problems about the older version of grammar class, and it was supposed to work differently, and therefore we have redefined it in 6E. So when we have for 6E, we have totally different grammar class, which is actually unrelated to 6C. Now, how does it work? Whatever. Let's suppose this is our 6C core, and we have class grammar here. Then we have 6D. Then we have 6E. Whatever, I'm trying to be as then we have eventually our code, program Raku, and then we create okay. Let me not close the braces for you. I hope it's readable. As you can see, and let's be persistent like this. Currently, we need preview for 6C. So as you can see, in this case, our grammar class gets resolved with the most, with the innermost definition of it, which is logical. It's lexical relations. Now, what happens if we change to 6D, for example? This frame is gone. And again, lexical relations, and we get the version of grammar from 6C. This is how our core works. Without understanding this basic, rest of the things doesn't really make much sense. As a diagram, it looks like this. So, as you can see, that's our lexical relation. And then that's about what I just shown you in more accurate way. Though here I used say, but whatever. Yes. Of course, demonstrations. At any time, if you forget accidentally how things look like, you can use a script of this kind and print all of your outers. So what does it do? I submit a stash to the subroutine, and then it uses outer special pseudo stash. Normally we refer to it like this, but then if we do it like this, it's actually the same, because this part, it ends up with kind of either stash or pseudo stash object, which is kind of a hash from the point of view of Raku code. So you see it here. I pull in outer of the stash I have received, and then I print the content of the stash just to see all the symbols. Now, look at this. 1 second. Did I do it? No, okay. It's not relevant. Okay, what we see here, first level, that's the innermost stash we get, or the innermost frame. Within this frame, we can easily identify it by our print outer subroutine. This is where it's registered. Then we go one step up in the lexical hierarchy, and we see an empty frame. Skip it for now, it's pretty much specific. Hi Liz, didn't see you been here already. And then look at this. This is our first core frame. This is our 6C core setting. You can identify it by simple names, like you see allomorph here. You can see operator definitions, infix. You can see actually say subroutine and so on. Well, nothing much to see here. But what if we change the language? What if we make it 6E and try the script again? Now you see two additional levels. Now you can see 6D core setting, and you can see 6E core setting. And remember, this is the innermost lexical. This is its outer lexical. Outer and outer again. So the resolution of a symbol goes from top to down. And whichever frame provides the requested symbol first, it wins. So 6E always wins against 6D and so on and so on. This way, we provide backward compatibility of language levels, so that when your code is specifically identified as 6C code, you always get your 6C language level. Yes. I don't know much about other languages and how they're implemented. But speaking of compiling languages like C, C++, Rust, whatever. Raku is extremely different from the point of view how we provide system libraries to user code. As you can see, in other languages, you link against libraries, meaning that symbols from that libraries are specifically imported, and I mean system libraries, language libraries. They get individually imported into your namespace. It also makes it pretty hard, actually, to maintain backward compatibility of language versions in some cases. As you can see, Raku approach is totally different, with where core is actually your part of your code, or more specifically, your code is part of the core. Your code lexically belongs to the core, and when you resolve something, it's not gets imported, but you have direct access to it lexically. Well, yes, let me leave this slide here for a while, because I don't think it would tell you much new information. I just want it to be here. The only thing I would probably need to say is that specifying language, implementing a language is extremely language version. It's extremely complicated thing. What I did, what I have shown you with the core, it's the simplest thing of all. Really, it's easy to do. It saves us a lot of nerves when it comes to backward compatibility at library level. But things get much more complicated when it comes to, say, behavior of a method, of a class. It's not always that we want to change to replace the whole class. Often it's a bad idea. Sometimes we want to change just a single method. And it's a big problem because a method belongs to its class. We cannot replace it easily. We just cannot do it because same class, actually the grammar I've shown you, the grammar example, say you have your script as 6C and you have a module which is 6C, and the module creates a grammar and returns it to you by some means, whatever. You don't get a 6E grammar in your 6E code. You actually get a 6C grammar. And you must remember about it. Because class is a type object, it's an object on its own. And grammar from 6E core and grammar from 6C core, they're different type objects. And instances they create, they correspondingly inherit all the behaviors from their languages. And no matter which code with what language version uses that object, it gets the interface of the language which created this object. Often it's a big problem, really big problem. And time after time, a question is raised, can we change behavior of this method depending on which version language calls it? And my answer always is no. Ooh, Liz, you hear me? No way. We don't change behavior of the method depending on which language calls it, because it would have action at distance. For example, you create an instance of such class where method behavior depends on what language version calls it, and your code is 6C, and you get used that it behaves this way. And then you import a module, which is 6C, and you pass an object you created into this module, and suddenly you start getting errors, and you don't understand what's going on. And what is going on is that because that method behaves as 6C in 6C code, and you didn't expect it. You want it to be as 6E, but it doesn't do it. That's bad. That's much worse than having a bug in a method, because when you have a bug, you know about it. You can probably deal without it. But when your method starts behaving differently in different circumstances, problems. Okay, this I have done already. And actually, I told you all this already, so finish. Yes, I just wanted to show you an example with last, which starting with 6E, can now accept an argument. That argument would become the return value of corresponding iteration of your map subroutine. So just we can skip it for now. Meta model. I'm sorry, 1 second. Okay, I'm sorry. As I said it earlier, that meta model, it's hard to relate it to either compiler or to the core setting, because it actually sits in between. Meta model is a kind of interface for the compiler and for the user at the same time. Спасибо. And we need to consider this role carefully. Technically, as you can see from this slide, meta model is not a part of core setting. From the point of view is it's not a lexical alter to your code. And when you think it is, because you can use something like meta model dot class how in your code, and you don't need anything, any specifics to refer to it. It's just a special glue done for you and for ease of use. But technically, meta model is a separate module which gets loaded separately, and its symbols are imported by the compiler whenever it needs them to be. Oops. Oh, okay. Also, I shall apologize. It wasn't possible for me to rehearse anything, so I really missed one more slide on meta model here. And Let's do it a little bit different. If you have any questions about meta model, just ask them now. Okay, no questions. Then I better skip it for now, because really I'm unprepared, unfortunately. So don't laugh at me, please.
I was saying, I think somebody has fallen asleep. Rob?
Yes, it's true.
Oh well. Can't win them all.
Is he from Europe? I don't remember. Because if he is, it could explain it. Time difference makes things much harder. Okay. The slide I missed, I forgot to make on meta model. It was supposed to be a bridge between actually the core and Raku code, and between and NQP code, because meta model is written in NQP. Just so, if you haven't noticed, when I was showing you grammar, then you can easily recognize pure Raku code. It's familiar. Things are different when we speak about meta model, because it is supposed to be the base of bootstrapping the Raku language. And say when we look at class how, for example, there is a way to easily distinguish between NQP code, which is a very much simplified and very much stripped down version of Raku language, and Raku itself. Is you will never see assignment in NQP code. It's only binding, because NQP doesn't have containers. It only has symbols. It has symbols which are always bound to some kind of value. So
You could argue
otherwise,
that the NKP only has objects and nothing else.
yes, also true. Another thing is you can suspect it is NQP is heavy use of NQP codes, like here. We also use them in Raku a lot to optimize, to speed up some core stuff, but generally they're not characteristic, of course, to Raku code. So back on track. As I said earlier, NQP is our bootstrapping language. What does it mean? When you start compiling Raku code, you already need to have some Raku code ready for it. This is a common problem of bootstrapping any language. Normally, it gets solved by language being compiled by some lower level language initially, and then the compiled binary used to compile the language itself. And eventually, some languages get to the level of self-bootstrapping, where they can compile themselves totally without involving any other language. It's not yet the case with Rakudo. Maybe it will be at some point, but not now. For now, we use NQP to bootstrap. Here is how it happens. and why meta model was supposed to be my bridge. As you can see, I load bootstrap NQP. That's the first file, the first code, which always get executed. Okay, let's skip it. Which always get executed when any Raku code starts. And this is the code where we get basic classes defined initially. You see, mu, any, nil, and so on, so on. This is a special kind of declaration provided by NQP where we specify that we want Raku class mu backed by Perl 6 metamodel class how, meaning that class how will be responsible for creating and maintaining class mu. Anybody familiar with metamodel would understand this pretty easily. It's not a big deal. There are some tricks. Let's not get too deep into those tricks for now. So the primary thing we have to remember is that NQP is what compiles Rakudo. Not only meta model, not only bootstrap, but compiler itself is written in NQP, and I mean Rakudo compiler, and some other bits as well. The more you get into cores, the more you find out about it. NQP codes I mentioned already, and yes, we do use them in Raku code as well. That's I hope the necessity of using NQP codes in Raku code will be gone in future, as soon as we get sufficiently complicated optimizators. Unfortunately, it's not the case yet, so we use them. And if you want to find out about the opcodes, there are different ways to read about them. First of all, as you can see, you can find them in NQP directory under docs subdirectory. My way of accessing this file is via GitHub. I just always have a page from NQP repository with this file opened in one of my tabs. There are similar documentation for opcodes defined by Rakudo itself for its own use. But currently we don't really care much about them. Yet those opcodes are not fully documented. The file itself is incomplete. Some opcodes are missing, and you would have to find some of them manually, either by using grep, as I mentioned it already, or you would be just knowing where to find them. For example, like this. I just know where it is. Compile. Say, here we go. It's almost impossible to avoid NQP list opcode. And here in this file, we find its definition. The interesting thing is that, yes, it is defined in this file. This is what gets invoked when we use this opcode. But there is corresponding opcode in more VM backend. So some opcodes, they're actually two-level. There is some proper NQP code for them, and there is the actual bytecode representation in the backend. So that's the next level. And that's actually why I say that it's not mandatory to know it's not mandatory to know C language, but it's would be extremely helpful. Come on. Okay, I cannot find the list itself, but as you can see, there are some other codes here. This is the source code of our more VM backend. This is the core file of it, named interp-c. It's actually the file where the execution loop is located. I mean, the loop which pulls in bytecode, a bytecode, executes it, gets the result, and switches to the next bytecode. And here you can find the use. Then you can find another calls where those bytecodes are actually implemented, their functionality, and so on, so on, so on. And basically, it's not necessary to understand that all, but sooner or later, believe me, you will end up there. You would need to read C code as well. Okay, now as we have the concepts, the necessary concepts, it